Okay, practice exam 2, points back, step 3. And guys, I just want to say that um, I know that I'm like, asking you to take notes on this, but really what would be best for your learning is if instead of just like, copying everything that I do, if you do a combination of copying what I do and then trying to take it from there yourself. And then, like go so far with me and then try to do some more of it yourself and then play the video again and see if you got it right. If not, fix it. You know what I'm saying? So just you want to try to do as much of this on your own as you can. Another way, which is probably the least um, effective, well, no, this is probably super effective, but like time management wise, it would take a lot of time. Ideally, it'd be great if you could like maybe just watch the video without taking notes and then do it yourself. Like try to remember the logic of the problem and do it yourself. That would be an amazing way to prepare. But I understand that time is an issue for a lot of you. But so I just wanted to say that. Okay, so consider the differential equation here where y is not equal to 0 because otherwise they'd be undefined. So the slope field for the given differential equation is shown below. Sketch the solution curve that passes through the point 3, negative 1, and sketch the solution curve that passes through the point 1, 2. Note, the points 3, negative 1, and 1, 2 are indicated in the figure. Okay, so what you want to do, and guys, you like all got this. Okay, so this is going to be worth 2 points. And okay, so the solution curve through this point, I want to try to follow the pattern of these slopes. So it looks like it goes, I don't know, something like this. Yeah, something like that. Okay, so if you did that, you got +1. You got 1 point. Now the other one is harder. The solution curve that goes through this point here, you might say to yourself, oh, it looks just like the other one, like this sort of thing. However, guys, what I'm realizing is that when they want the solution curve, especially if you read further in the problem, they're talking about y equals f of x. Okay, so this is a function. So it's kind of becoming clear to me that they want these solutions to be functions. Like they want you to solve for y. I kind of thought the solution could not be a function, which I think is true in some cases, but it seems to be like for these free response questions, they want the solution to be a function. And remember the vertical line test for a function? If you went like this, it would not pass the vertical line test. So this would not be a function. This one is a function, but this would not be a function. So in order for it to go through this point, you only are going to use like this half of that full pattern. And also y is not equal to 0, so you would need like an open circle there. So this would have given you the other point. All right, so that would have given you another point right there. That is a hard point to get though, I think, for a lot of people. Honestly, I would have done the whole thing, until I saw the answer and thought about it. Okay, so part B, write an equation for the line tangent to the solution curve that passes through this point. All right, so you need the point of tangency and you need the slope, which is f prime. So the point of tangency, they're telling you. Oh, and by the way, guys, organize your work really well. All right, because you don't want them to have to go looking for the answer, because if they have to go looking for the answer, they might not see it if it's there. So this is for part B. Point of tangency is 1, 2. That's what they're telling me. I need the slope. Okay. Well, guys, they're giving us this equation, which gives the slope at any value. All right, so the slope is equal to, Okay, so the slope is equal to dy dx. That's just another way of saying f prime. And then this is just Leibniz notation. So evaluated at the point 1, 2. All right, and if you don't do this exact notation, it's okay. So this just means that I'm taking dy dx and I'm plugging those coordinates in for it. So I end up with 1 over 2. All right, and then I go y minus blank equals blank, x minus blank. So 2½ 1. Guys, you can stop there. You can stop right there. And I would, unless you need to solve for y, like you need to graph it or something, or they ask you to solve for y, I would just stop right there, because the danger, you could undo, this is only a 1 point. This, believe it or not, is just 1 point. And if you make a little, like, if you are trying to like solve for y and you just make a silly mistake that we all make every once in a while, I make them a lot, you could lose all of that point. All right, they're not going to give you a half a point. All right, so B. Now C. Now, most of you did not get this, but you can get this. I know that you can, especially after our training is done. So find the particular solution, y equals f of x, to the differential equation with the initial condition f of 3 equals -1, and state its domain. This was hard. Nobody got the domain part, but that's okay. All right, so for C. All right, so I've got to take the differential equation. All right. I have got to separate the variables. So I basically like cross multiply. So y dy equals x dx. Guys, right there, you get a point. All right, so if you got all of these 4 things, you would have gotten 4 points, which very well could be above the national average that was for this problem. I don't know off the top of my head. Okay, now this is important for your notation. You've got to now go like this. Right, this is just a notation issue. So go like that. That means that you're taking the antiderivative now of each side. All right, so this one is 1/2 y to the second. Guys, right there, you would get another point. All right. I'm a little iffy on whether they would take off for the integration signs. I think they would, though. Okay, now we have got to... Okay, so now we've got to find C. All right, so we've got to find C. So we're going to plug in this here, because that's the initial condition. So in for y is going -1. And in for x is going 3 plus c. So this is 1/2 equals 9/2 plus c. So you get that c is equal to -8/2, which is equal to -4, okay? And then, so this is 6 points total. 1, 2, I think you get 3 points here, maybe. This might be another point, okay? And then the 4th point was solving for y. So I got to plug this back in. So I've got 1/2 y squared, 1/2 x squared plus or minus 4. All right, we got to solve for y. So you've got to divide both sides by 1/2 or multiply both sides by 2. All right, right, that would cancel that out. So you get that y squared is equal to x squared minus 8. And if you don't understand something, you've got to pause and try to understand it. So if this is not clear to you guys, it really needs to be. And then you got to take the square root of both sides. So y is equal to plus or minus the square root of x squared minus 8. However, it can't be both. All right, this has to be a function. It can't be both. All right, so, oh yeah, guys, this initial condition is this point here. All right, it's that point right there. So this is the solution graph, or so this solution curve is the graph of the solution that we're getting here. So it's the negative one. All right, it is the negative one. So y is equal to negative radical x squared minus 8. All right, 1, 2, 3. This is supposed to be 6 points. Oh. I think having the constant of integration there is another point. I think. Yeah, 1, 2, 3, 4. This is 5. And now for the last point is this pesky state the domain. I just say pesky because I know you might have to think about it. All right, so what is the domain of this? Well, guys, you have to ask yourself, all right, how do you do the domain of a square root function? You take what's under the square root. Okay, so I'll say over here. So for domain, x squared minus 8 has to be greater than 0. Notice I'm saying greater than. I'm not saying greater than or equal to because y cannot be equal to 0. All right, so I'm not saying greater than or equal to. So we've got x squared is greater than 8. No, this is not how you do it. You don't do it like that. You have to, yeah, you kind of like have to factor this. All right, so you could do a difference of 2 squares on it. So it's x plus radical 8, x minus radical 8. Okay, and again, if that doesn't make sense, then please think about it. And then you do like a number line. So whenever you're trying to check where something's positive, where something's negative, you do a number line on it. So this would be negative radical 8. This is positive radical 8. And then I've got to pick testing points. If I choose something over here, I get negative times negative, so positive. If I choose something here, like I get a negative. If I choose something here, I get a positive. All right, so you say to yourself, okay, so the domain is maybe this, and that, but no, it's not because, okay, so this has got to be the domain. Because, and guys, the way they do these problems, they really build on each other. I keep going back to this original graph. So this is the solution curve to this right here. And look at it. What is its domain? It's the x values all the way to the right of this. So it's this one here. All right, so that's the domain. So, so domain, all right, so domain is all x's that are within this interval. Okay, I will talk to you later.